Welcome to The Explainer. Today, we're taking a look at the fascinating, highly scientific journey happening right behind every single meal you eat. We're going to break down exactly how raw, super-perishable farm commodities actually get transformed into the safe, sustainable, and highly specialized nutrition you pick up off the grocery store shelf. Think of it as your ultimate backstage pass to the modern food system.
So to really get into this, we have to start with a pretty massive question. How did our primitive, fundamental need to just keep food edible through the winter turn into this incredibly complex, high-tech engineering of human wellness? Because it's a wild journey, right? Going from basic survival to highly sophisticated science, and it literally impacts every single one of us, every single day.
Let's kick things off with Section 1, the societal shift, survival versus wellness.
To really understand the architecture of modern food, we first have to ask why we even bother intervening with nature in the first place. Historically, the imperative was, well, strictly survival. We relied on things like sun-drying, salting, or very basic fermentation just to guarantee a continuous food supply and improve basic digestibility so people wouldn't literally starve during the off-season. But contrast that with what we demand today. Now we expect our food to be shelf-stable, organically sourced, nutrient-dense, visually perfect, and functionally fortified. We aren't just surviving anymore. We want top-tier quality and wellness, and we want it delivered at an absolutely massive scale.
It's super interesting to dig into the actual drivers behind this shift, because it didn't just happen by accident. Massive cultural changes actively pushed this forward. Specifically, you had rapid urbanization and this huge rise in working professionals who, frankly, just no longer had the time to farm or prepare food from scratch all day. You combine that kind of lifestyle shift with an agro-surplus economy, and suddenly the entire focus pivots from desperate preservation over to quality, convenience, and scale.
Which brings us right to Section 2, the battle against spoilage.
Because at the end of the day, all of this innovation stems from one very stubborn, universal problem. Raw agriculture is incredibly perishable. From the absolute second it's harvested, it's under attack. And the biggest vulnerability happens in a very specific temperature window, between 5 and 60 degrees Celsius. In the industry, we call this the danger zone. When high-risk, protein-rich foods like meat, fish, poultry, or dairy sit in this range, microbial growth doesn't just slowly creep up, it accelerates exponentially.
So we're basically fighting a constant, multi-front war just to keep an apple acting like an apple. If you picture a sort of spoilage radar, you realize it's not just bacteria popping up. We are fighting internal chemical threats like oxidative enzymes that naturally degrade plant and animal tissues from the inside out. And then, on top of that, you have physical and environmental threats pushing in from the outside. Pest infestations, the wrong temperatures, light radiation, excess moisture. Honestly, it's a relentless siege.
So how do we fight back? Section 3, defining the interventions.
To win that battle against spoilage and keep the whole system running, human ingenuity came up with a highly specific set of tools and disciplines. Now, people throw these terms around interchangeably all the time, but they're actually very distinct, sequential steps. You start with food science. That's the foundational study. Then comes food processing, which is the actual physical action you take. After that is food technology, the engineering application. And finally, food manufacturing, which is how you scale the whole operation up for the masses.
Think of it like a giant funnel. It really helps demystify the buzzwords. You start super wide at the top with the foundation, using chemistry, physics, and biology to study how things spoil. That knowledge narrows down into the physical actions of food processing to transform the raw ingredients. From there, food technology applies science to safely preserve and package it all. And finally, it funnels right down into mass manufacturing using tech principles to pump out safe food that meets the incredibly diverse dietary needs of a growing global population.
And if we look at the timeline of how we got to this point, the momentum is just incredible. We kicked things off back in 1810 when Nicholas Appert totally revolutionized long-term storage with the canning process. Fast forward a bit to 1864, and Louis Pasteur drops his groundbreaking discoveries on the microbial basis of spoilage. By the time we hit the 20th century, global conflicts and logistics are driving this massive need for instant, ready-to-cook convenience, which sets the stage perfectly for our current 21st century era, where the absolute driving focus is on health, wellness, and functional foods.
Now for the actual mechanics. Section 4, the Preservation Control Panel.
How do scientists actually execute these interventions in the real world today? How do we literally stop the rot? Well, I like to think of food technology as a massive instrument. Scientists are effectively manipulating very specific dials on a control panel. You've got temperature control, dropping it to freeze or slow down molecular activity. You've got heat application, using incredibly precise thermal processing, like cranking it up to 121 degrees Celsius to actively destroy pathogens. Then there's moisture removal, dehydrating foods to pull out the water microbes need to grow. You can turn the acidity dial to lower the pH, creating a super inhospitable environment for bacteria. And lastly, oxygen management, controlling or entirely eliminating oxygen to prevent oxidation and suffocate aerobic microbes.
And here's the cool part. Depending on how hard you turn those specific dials, you land on different levels of an intervention spectrum. It's essentially a 7-step journey. Down at level 1, you have minimally processed organic integrity foods. Think just basic cleaning and refrigeration. Move up the spectrum and you get into preserved foods, manufactured items where the original raw characteristics are gone, and then formulated foods. Keep going, and we hit purified food derivatives and then functional foods engineered for active health benefits, like adding probiotics. Finally, at level 7, you reach the absolute pinnacle of high-tech engineering, medical foods. These are explicitly tailored to manage dietary diseases like perfectly formulated lactose-free milk. Which leads us perfectly into Section 5, Engineering Modern Nutrition.
When we get to that super high-tech end of the spectrum, we hit the ultimate goal of modern food manufacturing, actively engineering specialized health and wellness directly into the things we eat. To do this, scientists basically rely on 2 distinct philosophies for improving public health. The first is addition, otherwise known as food fortification. This is literally just adding lacking nutrients right into everyday staple foods to fight widespread deficiency. The second philosophy is substitution, or wellness alteration. This is where we change the nutrient profile by completely swapping out ingredients to fight lifestyle diseases like heart disease or diabetes.
On the addition side, you see this with standards from organizations like FSSI, which mandate adding iodine to salt, folic acid to wheat flour, or vitamins A and D to milk and oils. It is a wildly effective, brilliant way to deliver a baseline of health to an entire population. But over on the substitution side, scientists are doing some next-level stuff. Think about replacing empty sugar calories with zero-calorie artificial sweeteners, or, and this is a great one, taking the fat out of ice cream and swapping it with specially treated protein mimics. You drop the calories, but you completely preserve that rich, smooth texture that consumers absolutely demand.
Bringing this whole thing full circle, we can see the complete loop, and it's completely driven by the food technologist. They take that vulnerable, highly perishable agronomic yield right from the farm. They apply those 5 scientific principles we talked about: heat, water, temp, pH, and oxygen. They scale it all up through manufacturing to guarantee food security. And then they deliver that fortified, safe, ultra-convenient nutrition right to the consumer. And as our wellness demands continue to evolve, those new expectations create new requirements that feed right back to the farmers. It is a continuous, beautiful, self-improving engine of human sustenance.
It's an absolutely incredible evolution, isn't it? To think that human beings started out just desperately trying to sun-dry fish so we wouldn't starve in the winter, and now we are literally engineering the molecular structure of our meals to actively prevent chronic disease. It really leaves us with a fascinating question to chew on. As our scientific control panel gets even more precise, and as we understand human biology better than ever, how far will we push the architecture of our food in the future? Seriously, what is going to be on your plate a century from now? Thank you so much for joining me on this explainer. I really hope you look at your next meal with a whole new level of appreciation.